Assalamualaikum and good day. Today kita akan masuk on chapter 3, deflections of beams. What does it mean by deflection? A beam may be strong enough to resist safely the bending moment due to the applied load and yet not suitable because its deflection is too great. Excessive deflection might not only impair the strength and stability of the structure but also give rise to minor troubles such as cracking of plaster ceilings, partitions and other finishes, as well as affecting the functional needs and aesthetic requirements. Deflection, for example, if you have beam like this, okay, and this is what we call front view. So your beam supposedly to be look like this, but when there's a force that acting on top of the beam, okay, if let's say it is too excessive, maybe beam tu akan deflect. So when it deflect, dia akan melengkung like this lah. Okay, dia akan like melengkung. So this is what we don't want. Kalau excessive deflection, it might not only affecting the functional needs. Okay, maksudnya beam ni perhaps dia akan sebenarnya tak boleh support load tu sendiri because of dia dah deflect, and also aesthetic requirement. So bila dia deflect like this, not only beam ni akan crack, dia akan affect juga brickwork below the beam itself. Brickwork kat bawah tu pun mungkin akan crack juga. So factors affecting deflection, we have 4: load, span, size and shape of the beam, and also the stiffness of material. We're going to look one by one. So first here we have load. Beam A and beam B represent beam of span L meter supported simply at its end and carrying a point load of W kilonewton at mid span. Jadi beam A dengan beam B sama panjang, okay, and carrying a point load at W kilonewton, meaning at mid span, maksudnya dekat tengah-tengah. Okay, kalau kita tengok kat sini, apa beza between these two beams? Okay, semua yang lain sama. Contohnya materials beam ni sama, the size of the beam sama, the length of the beam also sama. The difference is the loading. Beam B, the load is twice of beam A. Assume that the deflection due to the load is 5 mm. It is obvious that if the load is increased, the deflection will increase. Jadi bila load ni, contohnya here beam A dia W, tapi beam B twice of W, maksudnya 2 darab W, 2 kali ganda. Kalau beam A, perhaps dia punya deflection adalah 5 mm. This is example only. So kalau W kilonewton, the deflection is 5 mm. However, kalau katakan ni 2 kali W, so dia punya deflection akan jadi double, which is 10 mm. Okay, perhaps kat sini 5 mm ni, this is example only. Okay, here kalau katakan dia punya loading double, okay, you nampak kat sini 2y, maksudnya 2 darab 5 mm tu lah. Jadi dia jadi twice the deflection. It can be proved that the deflection is directly proportional to the load, which means that bila you keep on adding the load, berat dia akan tambah bersama-sama as much as the load yang you keep on adding tu. And then we're going to look at the second one, which is span. The load W are equal and the weights of the beam, which are assumed to be equal in cross section. The span of the beam B is twice of beam A. Beam A dengan beam B sama dari segi loading sama, size dia sama, cross section sama, and materials also sama. The difference here, beam B span dia adalah twice, 2L. Sini you nampak 2L meter, and this one is beam A adalah 2 meter. It is obvious that the deflection of beam B will be greater than that of beam A. So logically, if we see that the longer the beam, the greater the deflection. Instead of the deflection of beam B being twice of A, so instead of kalau you nampak length dia makin panjang ni, dia bukan jadi twice. Kalau you tengok here, the deflection akan jadi 8 kali daripada kalau panjang dia L meter. Padahal kat sini panjang dia double saja daripada L meter tu. Okay, why? It is 8 times. If the span of beam B were 3L, its deflection would be 27 times of beam A. In other words, deflection of beam is proportional to the cube of the span. Therefore, L3 is the term of deflection formula. What does it mean? You see that this is L meter and here is double the L meter tu lah, maksudnya twice twice panjang dia. So 2 you kuasa 3 kan. Okay, sebab dia kata L kuasa 3. Okay, you will get 8. So 8 darab dengan the deflection yang beam A ni. Okay, so 8 akan darab dengan, for example, Y meter dia I letak contohnya 2 mm. So 8 kena darab dengan 2 mm. So dia akan jadi 16 mm. Kalau the length adalah twice longer than beam A. Okay. Kalau 3L here perhaps I give example, another example, perhaps 3L. Triple the size of beam A. So 3, you power of 3 here, then you will get 27. Here bukan 8 lah. So 27 times 2 meter. Sebab kalau katakan length dia adalah L meter, deflection dia is 2 meter. Okay. Jadi you kira you darab lah 27 darab 2, you will get 54. Okay. Kalau 4 kali, so 4 kuasa 3. So 4 kuasa 3 you dapat berapa? So you akan darab dengan berapa deflection kalau katakan panjang beam tu L meter. Okay. Like this example lah. And then we have the size and shape of the beam. Here you see the beam of equal span and loading, but the moment of inertia of beam is twice that of beam A. So beam A and beam B sama dari segi the length, the weight, the load that you going to apply on the top of the beam, and also the materials. Yang beza kat sini adalah cross section dia, maksudnya size and shape of the beam. If you see here I-axis, beam B I-axis-nya double daripada I-axis beam A. Maksudnya dia lagi besar lah. Okay. And then you put the same load on top of both beam. Obviously, the greater the size of the beam, the less of deflection. Okay. Bila you nampak macam ni, maksudnya obviously, it is so obvious that kalau kita tahu semakin besar beam tu, deflection dia akan semakin kurang. It can be proved that the deflection is inversely proportional to the moment of inertia. For example, the deflection of beam B will be 1/2 of beam A. Moment of inertia I is therefore a term in denominator of the deflection formula. It can be noted that since the moment of inertia of rectangular cross section is BD cube over 12. For example here, kalau you dapat I-axis for beam B double daripada beam A. Jadi you ambil je dua ni, you akan tahu dia punya deflection akan jadi 1/2 daripada beam A. Dia akan jadi terbalik. Kalau katakan this is 3. Okay, triple the I-axis of beam A. So kat sini dia punya deflection akan jadi 1/3 Y. So for example, if let's say I put here 2 mm for I-axis, size I-axis macam ni, jadi 1/3 darab dengan 2 mm lah. Okay, tu maksud dia. Okay, and then we have stiffness of material. Stiffness of material is measured of the resistance it has to bending deformation. The stiffer the beam, the less it will bend. The stiffer material, the stiffer material of the beam, for example, greater is resistant to bending, the less will be deflection. Other conditions, for example, span, load, etc. remain constant. So condition lain sama. Okay, loading dia, span dia, IXX dia sama, tapi dia punya material saja yang lain. The measure of the stiffness of material is its modulus of elasticity, and the deflection is inversely proportional to the value of E. So sebenarnya every materials tu ada dia punya value of modulus of elasticity, macam I explain dalam chapter 1. Bila you tengok semakin tinggi yang modulus of elasticity, maksudnya semakin elastic lah that particular material. Bila you tengok makin ke bawah ni, contohnya brick, so dia semakin stiff, dia semakin tidak elastic. Semakin ke atas ni, ini semakin elastic. So if you see here, besi ni semua lebih elastic, and semakin ke bawah ni semakin stiff lah materials tu. Alright, that's on the factors. Now we look at how we're going to find the deflection. We have few methods that we can use. Actually, in your syllabus, it has been required for me to teach you more moment area method. This one, more moment area method. But I think that I'm going to opt to teach you Macaulay method instead. Although you're going to get the same answer, you have no problem in getting the answer, but it's just that the jalan kerja dia, okay, how you're going to calculate it will be different. So more moment area method ni, I reluctant to teach you because you need to draw the SFT and BMD, and later you kena dapatkan area bending moment daripada bending moment diagram tu. You can dapatkan the area. So the area, if let's say you dapat area as simple like something like this, okay, you will not have problem lah nak dapatkan area ni berapa. Okay, but if let's say this one for BMD, so BMD, you know that bila you ada UDL, uniformly distributed load, there's a possibility you akan dapat like curve like this. Okay, curve. So this curve is not very easy for you to calculate because jenis curve ni banyak. Okay, half circle, bla bla bla. Okay, jadi banyak jenis. Bila banyak jenis, banyak dia punya formula that you kena tahulah to calculate the area. That's why I prefer to teach you Macaulay method. But this one, if let's say you ada belajar at math, probably you will be familiar with integration. But if you didn't learn about integration, meaning you tak ambil math masa sekolah menengah, perhaps you don't have any idea about that, but never mind. This is just a simple integration method that you boleh faham if I just teach the basic there. So for Macaulay method, we have the boundary conditions and also maximum deflection rules. Dia ada rules dia. Ini dia punya rules that you have to fulfill bila you nak kira guna Macaulay method. One of it kita akan belajar for simply supported beam, and for another one adalah cantilever beam. It's simply supported beam. Macam mana you nak kenal this type of beam? It has two support at the end like this. Okay, kalau you lukis, perhaps this is the beam. Okay, mungkin you akan lukis like you have roller and you have hinge or pin support. So this is simply supported beam. So for simply supported beam, it says here the boundary condition, when x is equal to 0, y will be equal to 0. Which means here, daripada sini, okay, dia akan start dari kosong. Dia akan start, okay. Ini adalah panjang x, which we don't know kat mana that the point of x. Anywhere in between the beam lah. Okay, selagi ada beam ni, itulah dia x. Ada x dekat situ, kita tak tahu kat mana. So, bila x sama dengan kosong, which means here lah, at this point, Y akan sama dengan kosong. So, X tu jarak, distance tu, and Y adalah deflection. So, bila you belajar pasal equation about Macaulay method, deflection and such, kita memang guna Y tu as deflection and X tu adalah distance. And for the second boundary condition, X equal to L, Y will be equal to 0. So here, when X is equal to L, maksudnya paling hujung, because you know that the beam is L meter L, and then the deflection will be 0. So what we can see from this boundary condition, it means that whenever there is a support, there is no deflection. Obviously lah, sebab dekat support kan, macam mana dia nak deflect? Kat bawah ni deflect lah, meaning daripada sini sampai sini ni, ini deflection. Dekat support, there's no deflection, 0. And maximum deflection occurs, okay, where the slope dy over dx is equal to 0. What does it mean? Alright, so dalam gambar ni, as you can see, dekat sini, maximum deflection, for example, it happen here, dia straight line dekat mana maximum tu dia akan straight. So, there is no slope. So, slope tu sebenarnya dekat sini, contohnya, you nampak ni ada slope. Okay, nampak dia ada macam like angle like that. So, this is slope. But when it reach the maximum here, beam tu dia akan go straight a little bit there. So, there is no slope. Which means dy over dx sama dengan kosong. So, dy over dx ni adalah slope. Where dy over dx sama dengan kosong, kat sini lah dia y maximum. Alright. Then we going to look at for cantilever beam, Macaulay method. Apa lagi dia punya rule? So, for cantilever beam, macam mana you nak kenal? It looks like this. Beam perhaps akan tergantung hanging, maksudnya dekat sini biasanya akan ada fixed support. Okay, hujung sini adalah free end, tak ada support. So kat mana beam macam ni, usually you will see normally dekat awning, atap awning tu. Kalau you tengok you pasang awning dekat rumah, kat atas ni ada atap you, and dia ada all the truss and everything. So truss ni kat sini tak ada, nothing kan, tak ada any support here. So this is cantilever beam type. So for cantilever beam, it says that the boundary conditions x sama dengan kosong, y sama dengan kosong. Okay, jadi start daripada here, it is 0. X can be anywhere. Okay, bila x sama dengan kosong, which means here lah, kat sini kosong, y akan sama dengan kosong, meaning there is no deflection. As we know, when there is a support, the deflection will be 0. Okay, and then when x is equal to 0, dy over dx equal to 0. When x is equal to 0, dy over dx pun akan sama kosong. Maksudnya sekarang, if you look at here, kat sini tak ada slope. Okay, kenapa tak ada slope? Sebab dia memang tak ada slope lah. Normally deflection dekat support tu, for cantilever beam, dekat sini memang takkan ada slope. So dy over dx, and maximum deflection occurs at point where x equal to L. Meaning L ni berapa panjang ni? Hujung ni lah kan? Hujung you punya beam. Jadi when x is equal to L, dekat sini lah maximum deflection, y maximum. That one for rules for cantilever beam. And then we're going to look at example number 1. A horizontal steel girder having uniform section is 14 meter long. Panjang this whole beam is 14 meter. And is simply supported at its end. Jadi this is simply supported beam because you nampak ada dua support hujung ke hujung. It carries concentrated load of 12 kN and 6 kN at 2 points. 3 meter, one is 3 meter daripada 1 point, and 4.5 meter yang D ni pula 6 kN daripada 4.5 meter daripada 2 ends respectively. Given E, modulus of elasticity is 60 kN per millimeter square. Calculate the deflection of girder at 2 points under the 2 loads and the maximum deflection. Meaning, the question asks you to find Y dekat mana point C sebab dia minta dekat loads 2 point under the loads. And point D ni pun ada load. So, dia minta YD. And the other one, dia minta Y maximum. So, you ada 3 benda yang you kena cari. To find all this, what we need to do, kita kena dapatkan IXX. To calculate IXX, since the cross section is given, it says that the size of the beam is 150 mm times 200 mm. Then you can simply use the formula for IXX, which is BD cube over 12 plus AH square. Masukkan saja dalam formula BD cube. And we know that since this is a simple rectangular beam, tak adalah AH square ni, since H dia adalah kosong. The centroid is actually at the center of the beam. Therefore, there is no distance between the section yang you tengah kira, area tu tengah kira, ke section semua beam tu tak ada. Tetap kat sama point dia. Jadi, AH ni tak perlu kira. Bila you calculate, you dapat 100 times 10 power of 6 mm power of 4. And then what we need to find is, I nak kena cari reaction at A. Okay. Reaction dekat B tak perlu. Because bila kita kira Macaulay method, yang paling penting kira reaction dekat A. Tapi if let's say you nak kira reaction dekat B just for the sake of nak check sahaja pun tak apa. Tapi I tak kira lah. What we need to do is total moment at B. So right now, I memang take moment dekat B. Point B here. So all the distance I'm going to calculate ke point B. First we have reaction at point A, RA. So RA going to point B. Okay, this is clockwise. So that's why dia plus here. And then darab dengan 14 meter since the distance is 14 meter. Minus with 12 kilonewton because counterclockwise. Okay, negatif lah. Darab dengan 11 meter. Here, this is 11 meter the distance. And 6 kilonewton counterclockwise juga. Darab dengan 4.5 meter the distance here. 4.5 meter equal to 0. Maksudnya equilibrium. RA adalah 11.357 kilonewton. So, you boleh dapat lah. RB will not be included dalam you punya calculation sebab you memang take moment dekat point B. So, RB tak ada distance sebab ini adalah moment equation. So, moment equation mesti force darab dengan distance. So, since force dia RB lah, distance dia adalah 0. So, automatic dia cancel dan kita boleh dapatkan RA. Okay. Kita kena buat some equation. This one, if you see ada perkataan integrating ni, so dah termasuk dalam cerita integration yang you belajar at math dululah. Here, I buat the equation. Mx equal to, Mx tu moment dx. So, apa-apa sekarang kita tengah buat equation untuk moment. So, moment dekat x, so where is point x? So, point x can be anywhere along the beam. So, I tanda kat sini. So, kat mana-mana je point x ni boleh jadi. Starting daripada kosong sampai mana-mana point. Okay. So, kita nak take moment ke point x. So, 11.357 darab x. Sebab kita tak tahu kan kat mana. So, dia positif lah. Okay, kat mana point x? Tak tahu. Okay. And then minus dengan 12. So, negatif 12 tolak lah. Okay, tak tahu kat mana point dia. Counterclockwise, that's why negatif 12. Dalam kurungan x tolak 3. Kenapa x tolak 3? Sebab kita take moment dekat point x. Okay, dekat x. X tu can be anywhere here. Okay, anywhere on the right side. Jadi left ni, 3 meter ni tak masuk. That's why x minus 3. And then we have 6 kilonewton. And then this is counterclockwise also. Right? That's why negative. And then ni di sini x minus 9 Minus 9.5. Why? Because dia boleh pergi ke kanan. Okay, so kiri ni yang panjang 9.5 ni takkan masuk dalam berapa value yang you kena darabkan untuk panjang jarak dia tu jarak untuk kira moment. So anything mesti belah ke belah kanan lah. Jadi you minus dengan 9.5. So if you look at here, okay, this is you copy balik apa yang you tulis untuk mx ni untuk ei d2y over dx square. Because kalau dalam deflection, mx adalah bersamaan dengan ei d2y over dx square. Dia adalah sama. Okay. Jadi copy balik saja, you akan dapat equation yang sama. Integration. So kat sini yang kita ada benda sikit yang kita kena faham lah. For example, right. So we need to integrate. So dy over dx. Okay, bila di integrate dia akan jadi dy over dx. Okay, 2. Okay, you have x here. Dia kena darab dengan x. Okay. And then you bahagi dengan 2. Macam mana datang 2 ni bukan dari, not from here 2 ni actually come from this x darab x. So x darab x kuasa 2. So x darab x jadi x kuasa 2 kan. So 2 tu letak juga dekat bawah ni. Sama juga dengan 3. So 3 darab x. So x ni kuasa 1 kan. So dia bagi 1 kat bawah. Right? And every time you integrate, you kena ada satu unknown, which is here I boleh namakan dia apa saja. I can name it as b. You can name it anything, but avoid namakan dia as x and y sebab x dengan y ni ada maksud Bila you kira deflection, x dengan y tu ada something, which is y to deflection, x to distance. So jangan pakai x and y. Okay, I simplify kan. Okay, I boleh potong this one kan. Right? And this one jadi x kuasa 2, betul plus 3x plus b. And then I can integrate another time. Okay. So here I ada x kuasa 2 kan. So jadi x kuasa 3. Right. And you kena bahagi dengan 3. Because of here 3 ni. 3 di sini. Okay. You kena bahagi dengan 3. And then plus with 3x. Okay, darab dengan x. So dah jadi x kuasa 2 bahagi 2. So x darab x jadi x kuasa 2. So 2 tu you kena letak kat bawah juga. Bahagi 2. Plus bx. Sebab you kena darab dengan x juga. So since dia kuasa 1. So dia bahagi 1 lah. Tak ada apa-apa And then plus dengan another unknown. Because every time you integrate akan ada satu unknown. Which is perhaps you can name it anything you want. I letak z. So integration ni dia terbalik daripada differentiation. Kalau you belajar differentiation, dia akan go the other way around. Okay, so kita akan start integrate. This is simple integration, so you don't need to worry. Integrating. So ei dy over dx. You nampak dekat sini dia dah integrate daripada d2y over dx square. Dia dah integrate jadi dy over dx. Okay, 11.357 ni sama. So x darab x. That's why jadi x kuasa 2. Okay. 2 ni, don't forget untuk letak juga dekat bawah. Here. And then minus 12. Okay, sama. And then x minus 3. Okay. Darab dengan x minus 3. Sebab ini dalam kurungan. Okay, you don't need to expand it. Biar je dia dalam kurungan like this. Bila you nak integrate. Okay, so x minus 3 darab dengan x minus 3. So dia jadi kuasa 2 here. Sebab you dah kan x minus 3. Okay, you darab lagi dengan x minus 3. So dia akan jadi x minus 3 power of 2. Okay, so 2 ni bawa ke sini. Okay, itu maksud saya. And then same goes with 6 ni juga. So 6 x minus 9.5, okay, darab dengan x minus 9.5. So dia jadi kuasa 2 Jadi 2 ni sama juga bawa ke bawah. Right. And then plus C, because every time kita integrate, there will be one unknown. This equation, we're going to call it as slope equation. Or we can name it as equation number 1. Okay. And then we integrate it another time untuk dapatkan deflection punya equation. So dy over dx jadi y saja kat sini. Right? Sebab kita dah integrate dia. And then 11.357. So as you can see, so x kuasa 2 dekat dy over dx ni darab x. So jadi x kuasa 3. 3 ni bawa ke bawah. 2 ni don't forget 2 ni masih wujud sebab kita tak simplify kan. Bagi 2 dekat situ, jadi 2 ni masih wujud. Tapi kena darabkan juga dengan 3 dalam bracket tu. Right here. And then minus dengan 12. Okay. X minus 3. Okay. So you darab lagi dengan x minus 3. Jadi dia jadi kuasa 3. And you have to add tambah 3 kat bawah ni. Maksudnya darab 3 2 ni. 2 ni don't forget. Masih ada lagi sebab kita tak simplify kan dia. And kita kena buat darab 3. Since kita integrate another time. And then another one for 6. So 6 x minus 9.5. So x minus 9.5 darab x minus 9.5. So jadi kuasa 3 here. And 3 kat bawah ni. These two don't forget. Okay. Kalau you simplify 2 tu tak payah risau. Kalau for example kat sini you simplify kan. Contohnya you dah letak dia. You dah bahagikan dia. So kat sini you dah pangkah. So 3 x minus 9.5 power of 2 kan. Jadi kat sini terus je tulis 3 x minus 9.5 power of 3 divide by 3. Right. That one if you dah simplify. But if you tak simplify, don't forget that 2 tu ya. Carry juga dia sampai ke bawah. So that is for deflection punya equation. We call it deflection equation and kita namakan dia juga equation number 2. Okay. And then a C ni, Cx. C kena darab dengan X. Okay. Because C here we have C. So C darab dengan X. Jadi Cx. And you have to, so Cx ni, so X ni kuasa 1. So dia per 1 lah. And then every time kita integrate, there will be D as the another unknown. Since kita ada these two unknown here, then we going to use boundary condition untuk dapatkan value berapa D and berapa C ni. Okay, supposedly dia ada value, kita kena dapatkan berapa value-nya. To get that, kita kena check balik apa kita punya boundary condition. Okay, first condition we have is x equal to 0 and y equal to 0. So supposedly over here when x is equal to 0, y will be equal to 0. So we're going to use that boundary condition. Look at here. Okay, x equal to 0, y equal to 0. Okay, you nampak y. So y ni means that it is deflection. Okay, tak ada dy over dx kat sini, tak ada. Jadi obviously it is equation number 2 here. Since this is deflection equation, dia ada huruf y kat sini. Okay, jadi kita tahu x equal to 0, y equal to 0, it is for equation number 2. You gunakan equation number 2 ni, kena replace lah value x sama dengan kosong and value y tu sama dengan kosong. Here, I masukkan semua. So, y ni I dah replace kosong. And each x ni I replace dengan kosong. Right. C pun letak kosong lah sebab dia ada x kat sini for equation number 2. Alright. So, you kira. So, bila you nampak dekat sini, I ada slash. So, when I slash here y, because kosong minus 3, you dapat value dia negative. So, every time you dapat value negatif bila you calculate benda dalam kurungan ni, Okay, you need to ignore value ni ya. So kosong tolak 3 dapat negatif 3, dia dah negatif, ignore. And kosong minus 9.5, you dapat negatif 9.5, ignore dia, pangkah. Jadi bila you kira, okay, sebab 11.357 you darab dengan kosong, kuasa 3 tetap kosong lah. So here pun sebenarnya kosong. And here pun kosong. Jadi kat sini pun EI darab kosong tetap kosong. Jadi D adalah sama dengan kosong. Okay, that is for D punya value. And we have another unknown which is C. So for C, kita akan pakai another boundary condition, which is when X is equal to L, Y will be equal to 0. Means here lah, X sama dengan L, Y akan jadi kosong. Paling hujung. Kita tahu bila ada support, takkan ada deflection. Right. Jadi kita masukkan lagi dalam equation number 2. Since kita punya boundary condition tu ada huruf X and ada Y. X sama dengan L, Y sama dengan kosong. Dia tak ada dy over dx kat sini. Jadi kita tahu itu adalah equation number 2. So for equation number 2, which deflection punya equation, masukkan value ni dalam equation 2. L ni berapa value dia? So ikut panjang you punya beam. So since beam, panjang dia adalah 14 meter. From here to here, it is 14 meter. So ini panjang dekat sini adalah 14 meter. Jadi replacekan X tu dengan 14 meter. That's why I masukkan 14 as X. So X sama dengan 14. Replace everything. And since 14 tolak 3 ni semua tak ada yang negatif. So kita kena kira semua. And notice here also, yang value D ni dah jadi kosong. Sebab kita dah kira dekat the first boundary condition X sama dengan kosong, Y sama dengan kosong ni, kita dah dapat D is 0. Jadi kita replace je value D ni dengan kosong. So here it is D actually. So dah jadi kosong kat sini. Jadi bila kita kira, okay, so ada value here, bukan kosong. EI dapat C adalah sama dengan negatif 174.344. Okay, masukkan letter. Bila you dah dapat value ni semua, so you punya equation 1 and 2 dah lengkap lah. Sebab C tu you kena gantikan dengan this value, and D pun you kena gantikan dengan kosong lah. Okay. Jadi jangan tinggalkan, sebab ini you dah dapat value, masukkan dalam you punya equation. Alright. So what we need to do next is we need to calculate deflection dekat each points tu. Meaning point C and point D. Sebab kita nakkan YC and YD kan tadi. As I said, okay, you notice here. So ini value C tadi and X, right? So C ni dah di replace dengan value yang I dapat masa kira the boundary condition. And supposedly ada plus D here. So since D dah sama dengan kosong, so kita tak tulis lah. Okay, biarkan dia. And we know that for deflection at point C, 12 kN, substitute X sama dengan 3 meter. So Y 3 meter, since at that point, okay, point C, kalau you tengok ini 3 meter panjang dia, right? And untuk point D, this is 9.5 3 campur 6.5, this is 9.5 meter. This is 3 meter. That's why here kita akan replacekan X ni dengan 3 meter for C, and for D it is 9.5. Okay, jadi kita kena kira dekat these 2 points. Right, so use deflection punya equation. Sebab kita nak kira deflection dekat each point ni, we have complete equation already. Sebab kita dah kira the boundary condition. Masukkan saja value X ni dengan 3 And Y ni leave it like this. Y bukan sama dengan kosong. Okay. Y ni yang kita nak cari. Sebab kita nak cari the deflection. Y tu kita tahu it is deflection. So 11.357. So since X power of 3. So you gantilah semua. Right. So since 3 minus 3 sama dengan kosong. So you boleh cancel. And 3 minus 9.5. You akan dapat negatif 6.5. Kita tak nak value negatif, jadi kita cancel. And negatif 174.344, you jangan cancel pula ya. Because this one, dia bukan dalam kurungan. So you jangan cancel. Darab saja dengan X. Okay. And then simplify everything. Right. So you dapatlah negatif 471.925. So here you nampak I tulis units. Macam mana I dapat this units? Okay, since kita tahu 11.357 ni adalah reaction, which means force lah, kilonewton. Okay, and here 3 ni adalah distance dia, which is meter lah. And you see there is a power of 3, so kilonewton meter cube. That is the unit. Kat sini pun sama, semua sama sebenarnya unit dia baru boleh jadi equation. That's why dia boleh jadi minus, tambah, tolak-tolak ni semua. Sebab unit dia sama. Kita nak dapatkan value of Y. Right now, EIY. Okay. We want Y only. That's why we need to divide with E and I. So that's why kat bawah ni nampak 60 kN per millimeter square ni adalah the value of modulus of elasticity. And 100 times 10 power of 6 is the value of IXX. Replacekan dia. Okay, so for modulus of elasticity, you see the units is kilonewton per millimeter square. Ini dah given dalam question. Therefore, yang kilonewton ni, bila you dapat value 471.925 kilonewton ni, okay, kilonewton tak perlu tukar dia tu newton lah. Sebab you boleh cancelkan dia. The thing says you just kena tukarkan meter ni kepada millimeter sebab dia kilonewton per millimeter square, sebab you nak ikut modulus of elasticity punya units ni. Jadi you just kena tukar dia tu millimeter cube. So meter cube tukar kepada millimeter cube. Macam mana you nak buat? So 1 meter sama dengan 1000 millimeter. Kalau 1 meter cube, maksudnya 1000 millimeter ni you kena cube kan lagi. So that's why darab dapat 10 kuasa 9. Okay. 1000, so 3 kali kosong kan. 3 kosong darab 3. So 10 kuasa 9 So bila 10 kuasa 9, that's why jadi 10 kuasa 9 here. And then nak simplify macam mana you nak kira. So 10 kuasa 6 ni you boleh tangkal. So here 3 right. So 3 dekat situ, senang lagi you nak kira. Then here I dapat negative 78.654 mm. Negative tu means that beam you like this, right? And there is a force acting on it. So the deflection occurs below the beam. Maksudnya deflection tu dekat point C. So here YC, okay, YC tu value dia adalah 76.654. Okay, so ini beam yang asal. Okay, deflection tu kat bawah ni sebab ada force dekat top ni. Jadi beam tu turun sikit 76.654 below the x-axis of the beam. And for point D, we know that X adalah 9.5, right? And gantikan lagi sama je cara macam mana you kira untuk point C. It's just that X adalah sama dengan 9.5. Replace everything. So since 9.5 minus 9.5 here, dia akan jadi value kosong kan. 9.5 tolak 9.5 adalah sama dengan kosong kat sini. Jadi kita boleh cancel. And yang lain-lain ada calculation lah. Right. And then kat sini I dapat negatif 582.65. Unit dia sama. And kira cara yang sama and I dapat negatif 97.108. Negative tu means, okay, this is point D, point C. So here is YD lah. Value ni, panjang ni, value ni, it is 97.108. Okay, bawah daripada x-axis of the beam. You dah menjawab YC and YD. Another thing that the question asks you to find is the maximum deflection. Okay, the problem here, kita tak tahu kat mana maximum deflection. Okay, but we know the rules for simply supported beam. Kat mana sebenarnya maximum deflection happen? Okay, we need to refer to the rules. So maximum deflection occurs at point where slope is equal to dy over dx. Okay, bila dy over dx sama dengan kosong. Jadi bila dy over dx sama dengan kosong, so inilah rules dia. Jadi you tahu rules dy over dx, maksudnya equation yang mana ada perkataan dy over dx. So dia adalah dalam equation 1, which is slope punya equation. You ambil slope punya equation. Salin balik slope punya equation, masukkan dalam this, masukkan dalam calculation you lah. Jadi kita tengok balik mana slope punya equation. So this is slope equation. Okay, EI dy over dx bla 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 bla. And don't forget C ni ada value sebab you dah kira masa you dapatkan boundary condition. So C ni kena replace berapa value yang you dapat tu. Ini adalah slope equation tu. I dah tulis Nampak beza dia kat sini kuasa 2 tau. Okay, kalau deflection equation dia kuasa 3. Okay, jadi berhati-hati ambil slope punya equation sebab dia bagi rules dia dy over dx sama kosong. Jadi nampak dy over dx memang slope punya equation. Masukkan and here, okay, this is C yang I dah replace tu juga. Sebab I dah dapatkan value C. So negative 174.344 dalam equation ni. Right. Ganti kan. So you know that dy over dx adalah sama dengan kosong bila there is no slope. So EI dy over dx. So dy over dx sama kosong. That's why I replace dengan kosong here. And then 11.357 x power of 2 divided by 2. Ini semua adalah slope equation tu. And at the same time, you kena tahu yang mana satu yang you nak cancel. Kalau you nampak dekat sini, I cancel this one. Why I cancel that one? Sebab sebenarnya, kalau you tengok daripada you punya gambar rajah, which means this one, okay, daripada the beam itself here, you boleh agak dekat mana sebenarnya dia punya maximum deflection occur. Okay, it can happen anywhere. Okay. Contohnya lah like this. But maximum usually akan happen in between these two points. Maksudnya biasanya maximum deflection akan happen di antara C ke D ni Dia mesti lagi besar daripada 3 meter tapi okay, Y max ni happen dekat mana? Okay, antara 3 meter ke 9.5. Right, sebab antara this one panjang ni. So Y max can be from 3 to 9.5 meter. Kat mana dia jadi Maksudnya X sama dengan 3 meter ke X sama dengan 9.5 meter. Kat mana in between this jarak Itu yang you boleh nampak daripada the observation. Maksimum takkan jadi dekat sini. Tak mungkin. Sebab kat sini you nampak ada support. So maximum usually akan jadi dekat tengah-tengah. Especially bila the force itself duduk dekat dah berjarak dah ke arah tengah-tengah tu Kita boleh agak-agak dekat in between these two Okay, kat sini lah maximum deflection happen. So that's why I tulis X ni, maksudnya X tu kat mana maximum deflection tu akan happen. Normally akan jadi lebih besar daripada 3.5. So ni you punya force. So in between ni kan. So ini 3 meter. Kat sini 3 meter. Kat sini ada 6.5 meter. Okay, jarak ni juga. So antara jarak inilah. Okay, right. So 3 meter ke 9.5 meter jarak X. X tu kat mana maximum to happen. Alright. So kalau kata kan X tu adalah sama dengan 9.5. Okay. X bila 9.5, okay, 9.5 tolak 9.5 tetap kosong. Okay. Kalau X tu happen dekat 8.5, 8.5 tolak 9.5, you akan dapat negatif 1. Kita tak accept value negatif. Okay, jadi kat sini kita boleh pangkah. Sebab macam mana pun value ni tetap kita takkan kira. Okay, because of we know that the value bila you tolak any value yang dalam in between this, okay, antara 3 ke 9.5 ni, you letak 4 ke, you letak 9.5 ke. Kalau letak 9.5 sendiri pun dia memang cancel lah sebab kosong kan. Kalau you letak 7 ke, sebab X tu takkan lebih dari 9.5. Jadi tetap kosong lah kan. Jadi kita cancel. That's why I can cancel. But here you cannot cancel because if let's say X adalah 9.5, okay, value ni you kira 9.5 tolak 3 ada value. Dia takkan jadi value negatif, dia takkan jadi kosong. Sebab X akan jadi lebih besar dari 3. Whether it is 3.1, so kalau 3.1 dia ada 3.1 minus 3 dia adalah 0.1. Value dia tak negatif dan value dia bukan kosong. Ini ada. And minus 174.344. So ini adalah value C tadi. Okay. Kita kena simplify kan. So what I do next is 11.357 ni. I pangkah lah 2 ni. So I bahagikan 2 ni. So I dapat 5.679 X power of 2. And then 12 ni boleh cancel. So ini dapat 6 lah. Okay. This one memang cancel, tak payah peduli dah. Okay. And minus 174.344. Okay. Here, when you have like this kind of equation, you kena expand dia. Okay. So, I expand. So, you know lah how to expand X minus 3. Apa maksud dia cos 2 tu? X minus 3 kan? Darab X minus 3 kan? So, X darab X jadi X cos 2. Negatif 3 darab X jadi negatif 3X. And then negatif 3 darab X ni juga negatif 3X. And negatif 3 darab negatif 3 tambah 9. Okay. Jadi inilah dia. Right. And then kita darab 6 ni dengan semua value dalam kurungan tu lah. Okay. So ini you darab lah. Okay. Kembang because we need to expand dia and simplify kan dia, right? So negatif 6 darab X kuasa 2 dapat negatif 6 X kuasa 2. Negatif 6 sebab ini you dapat negatif 6X kan? Okay, so negatif 6X darab negatif 6X. So you dapat 36X and 9 darab 6 negatif 6 you dapat negatif 54. And then simplifykan lagi. Okay, cos 5.679 X kuasa 2 tolak 6X, you dapat value ni. And 36X ni masih lagi. And then 54 tolak 174.334, you dapat 228.344. So, you ada one equation. Okay, equation macam inilah. Sama dengan kosong sebab kita punya dy over dx adalah sama dengan kosong. And then using calculator, so you boleh kira pakai calculator untuk dapatkan value of x. Okay, kalau tak tahu nanti kelas tutorial saya ajar. For maximum deflection, okay, substitute. So since you kira calculator, you dah dapatlah kat mana maximum deflection. Okay, maksudnya sekarang ni you punya beam like this, right? So this is point C and point D. So maximum deflection occur dekat 6.749. Mungkin kat point ni. So maksimum kat sinilah Y maksimum. Tapi berapa value dia you tak tahu. You tahu dia jadi dekat 6.749. Tapi berapa sebenarnya value dia. Another thing I forgot to tell you. Okay, bila you tekan calculator, you akan dapat dua value which is 6.749 and 105.4. Yang mana satu value you nak ambil? Of course, you akan ambil value 6.749. Why? Sebab beam that you kira ni, beam you panjang dia 14 meter je. Tak sampai pun 105.4 meter. So, this one tak make sense. Beam you sampai 14 meter je. Okay. Jadi, 6.749 tu adalah value yang betul. So, 6.749, okay. So, dapatkan berapa Y max dia. That's why kita gantikan X ni sebab kita tahu maximum deflection happen at this point. Gantikan X ni ya. So, equation number 2 which is deflection punya equation because we are trying to find the value of deflection for Y max. EI Y. So, 11.357 gantikan all the value for X here. And cancel out bila you dapat negatif bila dia dalam kurungan. So that's why here I cancel. And then don't forget CX here. Because dekat sini actually you ada CX. Okay. Because this is equation number 2 okay. Kira saja you akan cara yang sama macam you kira YD and YC tadi. Okay. It's just that dia punya value X saja yang berubah. You dapat negatif 116.693. So this is memang maximum value sebab you nampak value ni besar. Negatif 116.693. Kalau you compare dengan C dengan D tadi, value YD and YC is less than this value. Sebab kalau you check nampak value YC, this is YC and this is YD kan. Negatif 78 and YD negatif 97. So Y maximum is 116.693. So perhaps Y maximum tu happen dekat point dekat tengah ni lah. Okay, paling sebab ini 6 point bla 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 tadi yang Y maximum punya happen tu kat sini 3 meter kan. Okay. Kat sini ni sampai sini adalah 9.5. So dia mungkin happen dekat sini Y max which is dah 100 lebih dah dia punya deflection. So itu yang kita dapat. Right? Right. So hopefully you understand on this example number 1. If you don't understand, you can ask me in tutorial class at later. Okay, later. Okay, so thank you so much everyone and have a good day. Bye.